thank you all for taking your time today and tuning in at this webinar. My name is Alfred Berglund, and I work at Turbulent today. I will be your host, and so this inline mixing technology and innovation and scalability webinar. Today is the first day, January 27th, and today I will be joined by one of our favorite suppliers called Fluitec, and this webinar will mostly be about static mixers today, static mixers and heat exchangers that we will go through. So our spokesperson, Tobias from Fluitec, will be joining us today. He has been working more or less 15, 16 years within the company, so he knows everything between heaven and earth when it comes to these type of mixers. Depending on where you are located, you have different contacts to contact us as at Tune. So for example, me, Alfred, I'm in Sweden and Norway. And if you're located in Finland, you will talk to a person named Olli-Pekka. If you're located in Denmark, you will speak to a person named Rafi. If it's the Baltic states, you will speak to a person named Andres. And if you're located in Poland, you will speak to Dorota. We have social media accounts. Please follow us on social media. We're located in Facebook, LinkedIn, and YouTube. So we post interesting articles about our suppliers, events like this one, and also post a few videos on our YouTube channel, where you also will be able to find parts of this webinar. Without any further ado, let's begin with today's presentation with Tobias from Fluitec. Hello, Tobias.
Hello, Alfred. Good afternoon.
Good afternoon. Nice to see you from here.
Okay, so then let's start with the introduction of our products. So we are a company located in Switzerland, designing static mixers and heat exchangers. So we are designing products for inline heating and mixing. So we can handle all pumpable fluids. We can heat and cool practically everything. So from very low viscous to very high viscous, and I will now tell you what is possible with our product. I will give you an overview. First, who are we? Then I will explain you what mixers do we have for turbulent flow, what mixers do we have for laminar flow, how are our mixer heat exchangers built and designed, and last but not least, I will tell you something about our very special sterile heat exchangers and mixers that we have in our program for food and pharmaceutical applications. So Fluitec is more than 25 years old, founded in 1993. Today we have 25 employees, a lot of engineers, and we have also our own manufacturing where we produce all our products in-house. We built a lot of different materials too. So we can handle all kinds of austenitic stainless steels, duplex alloys, Hastelloy, Inconel, titanium, nickel, and even more special products like zirconium we are able to handle. We have also standard products out of plastics like PP, PE, PVC, and more resistant PVDF or PTFE products. We have a lot of certifications in-house. So we are certified according to the European Pressure Directive AD 2000. We have the certification to produce module A2 in-house and do the certifications our own. We are ISO 9001 certified, And we can also supply ASME, EU stamps, and China stamps, but we don't have these certifications in-house. For these products, we work together with partners. So let's go to an overview on our company. We have 4 main fields where we're working in. So first, these are the static mixers, where also all began at Fluitec. We have very special mixer heat exchangers for the heat transfer up to very high viscous liquids. We have a part that are building reaction technology for inline reactions. And we do also build complete systems that can be used out of the box for productions. Today, I will explain you more about the static mixer and the mixer heat exchangers. And tomorrow, you can follow the webinar from my colleague, from Alan George, who is explaining you the reaction technology more in detail. So the static mixers, we start with the turbulent flow. Turbulent flow means these are products with very low viscosities. And we are speaking on a turbulent flow when the Reynolds number is higher than 2,300. For these applications, we have a very special mixer named Aquamix. Aquamix because of the water. And this mixer creates turbulences by a specific impulse. So then with this impulse, we generate 2 vortices turning against each other and dissipating a lot of energy locally in center, and this produces a very quick mixing effect. We see on this picture a mixture of a blue additive dosed in the center. We see the Aquamix mixer placed right after the dosing. And we see here these vortices which create this mixture inside the tube downstreams the mixer. The homogenization takes always place downstreams. So it's important for this mixer type that there is a part of straight empty tube after the mixer. We see here more in detail and how the liquid is distributed. And we can also see on this picture very nice these local high turbulences that are created by these 2 vortexes in the Aquamix. Fluitec is producing this mixer type since 2002, and we have them as low-cost mixers for chemical applications. We see here standard chemical applications. These mixers will just be put between 2 flanges and create the vortex in the tube that follows. They are used a lot in water technology, but we also have standard products for food and pharmaceutical applications. We have done a lot of developments in the last years, also on these turbulent mixer applications. And we do such optimizations by CFD calculations. And there we developed another type of static mixer that is called vortex. And this vortex type of static mixer has a reduced pressure loss against compared to the Aquamix mixer. And the energy consumption is lower. But this vortex mixer, due to the construction of the element, cannot be as simple mounted in a support ring as the Aquamix type, and therefore we still have the Aquamix type in our program. But if you need dosing pieces, then the vortex type of static mixer is a good and cheap alternative. And we have very quick delivery times for the standard products because we have them almost all the parts for them on stock, and we build them on the wish, on customer wish. Another type of static mixer in turbulent flow is the CSE-B type that we have in our program. This V type is used for dispersions, for emulsions, and mainly for mass transfer applications. So I'm going to summarize now all of the applications that we deliver mixers for turbulent flow. First is a big market is wastewater treatment, freshwater treatment, fuel blending, so mixing of biofuels with conventional fuels. We are doing neutralizations. We do temperature homogenizations in heat transfer systems. And last, we do also use this mixer type for Denox applications, where we inject ammonia solutions into flue gas. And there are a lot various food applications. And in the dairy industry, it's used a lot for blending of milk and stuff like that. Then we switch over to the laminar flow, which is much more difficult than the turbulent flow. So laminar flow we have when the viscosity is very high, the flow rate is very low, and that makes it more difficult for the mixer. So in the laminar flow we have no turbulence, and the mixing is only created by layering the high viscous liquids. I show this here. We see now how such a mixer mixes. So laminar mixer type does only mix in one direction, so in radial direction, and the mixer builds layers inside. So after every mixing element, the layers are smaller, and in the end, after a while, when the layers are small enough, the mixing is happening due to diffusion between the layers. So it's not like in a turbulent flow where you create a turbulence that creates the mixture. Here you create very small layers, and between these layers, the diffusion makes the mixing in the end. I have here an example video that shows a pretty difficult mixing task. Just let us have a look at it. So we have a viscosity ratio of 10,000 between the additive and the main flow. We are at a very low flow speed, and we can see in red the additive that is dosed in. And we can see that there is no turbulence. So these bubbles that we can see, they are splitted off on the bars, folded together with the main liquid again and again and again, until we have very small layers, and we allow to have the diffusion between the layers. And we can also see that for this, it's much more difficult, and many elements are needed to create a good mixture. So let's continue on laminar flow. In laminar flow, we have our mixers. They are called CSE-X mixers. And we use a micro-macro design. This is a trademark of Fluitec. Micro-macro means that we combine all kinds of different mixing elements together to get the best mixing solution at the lowest energy consumption. We always develop our mixing elements to have the newest state of the art. We do that by freezing epoxy hards resins and cut it. So we see here models that are done by cutting epoxy resins. And we do also do such simulations in CFD, in computational, with the computer simulations. And we can see that these models on the computer, they give us a very good idea how it works in real life. And so we can do fast developments on our mixers in our laboratory. Here you can see such a simulation, and we use there these path lines inside the static mixer to see where the flow speeds are high, where they are low, and like this we can optimize the geometry of the static mixer for a very homogeneous flow and a good mixing efficiency. In the laminar flow, we have different kinds of static mixers. So this is our CSE-X6 type. The X6 type is the newest mixer in our program, has the lowest energy consumption and the best mixing and residence time distribution inside. We did reach this goal by opening the wall areas. We can see here these openings to the wall and also parts of the center. These openings, they reduce dramatically the pressure loss by an unchanged mixing quality compared to the CSE-X8 type mixer. And now I give you a short overview of all our mixers in our program. So firstly, this new mixer that we have in the program with a reduced pressure drop, with a very narrow residence time distribution. And this mixer is very universal, usable for almost all mixing tasks. Then we have a mixer named CSE-X8 in our program. This mixer is already pretty old. It was developed in the 70s, and we have it in our program since we are building static mixers. It's a very robust and universal usable mixer, but with a very high pressure loss, so high energy consumption. But for difficult application, it can still have advantages against our new mixer. I already had some words on our micro-macro concept. Micro-macro concept is a combination of different type of mixers, and with this combination, we can take best out of all our mixers and combine it to have a good performance and a low energy consumption. And we have also a very special mixer in our program. This is our high performance mixer. This mixer has an improved efficiency on special applications with high concentrations of low viscous additives. And this mixer has also a very narrow residence time distribution on low flow speeds, and this can be used therefore for residence time columns in the reaction technology. Okay, where are the mixers used in laminar flow? So this is one example is the producing and processing of polymers. So these polymers have very high viscosities. in food processing. So we process sugar masses, chocolates, fats, and all kinds of liquids. And in chemistry. In the oil industry, it's also used for all kinds of applications. Yeah, and here we are. I explained now our static mixers. To get the best design for a static mixer, please contact Tourne, and they will forward your request to our design specialists in-house, and they can tell you which solution is best for their problem. And now I will explain you more about our heat exchanger. This is a very unique product developed about 18, 19 years ago. And this is a heat exchanger that is used in very difficult applications. What was the idea behind when we developed our heat exchanger? So we wanted to create a heat exchanger that has the advantage of a static mixer, narrow residence time distribution, and high heat transfer coefficient, and of a multi-tube heat exchanger. And therefore, we just combined heat exchanger tubes with static mixers. And this is how such a product looks like. You can see this is a U-type bundle. So the heating cooling liquid enters here, goes through the bundle in the small tubes, and comes out on the other side. And the product is flowing around the small tubes through the mixing elements, is mixed and heated or cooled at the same time. So what are the typical characteristics of a static mixer heat exchanger from Fluitec? We have these heat exchangers in our program starting from a very small size of 6 millimeters, and the biggest heat exchangers that we have built have almost 1 meter of diameter. We are using these heat exchangers at flow rates from 0.5 kilograms an hour in our laboratory applications in the reaction technology. And we do scale up these heat exchangers up to 50,000 kilograms an hour for large production scales. We can handle viscosities up to 20,000 Pascal seconds. So these are 20 million centipoise. We get Bodenstein numbers up to 400. Bodenstein number is a number for the residence time distribution, and 400 means already a very narrow residence time distribution in the heat exchanger. And we can handle working pressures up to 800 bar in these heat exchangers. And for the polymer processes, it's no special thing to have temperatures up to 400 degrees. So now about something about the technique of the heat exchanger. Our heat exchanger has a very high heat transfer coefficient, means on a small volume, you have already a very high performance in such a heat exchanger. Here we see the field of the heat transfer coefficient of a mixer heat exchanger. We have a lot of different designs, and that's also why this field is that wide. But if you compare it to a static mixer with a double shell or a steered tank with a double shell that's heated, or even an empty tube with just a double shell, you see that the static mixer heat exchanger is in a range that's a lot higher. What are the fields of application for our mixer heat exchanger? So we use them in polymer production and processing. So in polymer industry, the viscosities usually are very, very, very high, and it's very difficult to handle these high pressures and high temperatures. And with our heat exchanger, this is possible. We are tempering all kinds of liquids from low viscous to high viscous. The best range of application for a static mixer heat exchanger is when the viscosity is higher than 300 centipoise. We do also cool and heat viscous food products with these heat exchangers. So a lot of chocolate products and stuff like that are produced with our heat exchangers. And we use this heat exchanger as residence time reactors for highly exothermal reactions. And we can build up a very safe system with this heat exchanger because of the high heat transfer coefficient and the good mixing efficiency that we have inside. We do also build a multi-tube heat exchanger. This is exactly the opposite of a mixer heat exchanger as I have shown before. It's also a mixer heat exchanger, but in this case, the heating cooling liquid is around the small tubes. And in the small tubes, we have placed static mixers. So the main flow is distributed to all these, the product flow is distributed to all these small tubes with mixers inside. And therefore, it's only used for applications that are not that critical. And some applications are energy recovery for viscose products in cooling processes. Mainly heating of viscose products and a lot of other applications. So we are already almost at the end of our presentation, and we have some special products for pharmaceutical and also food applications. So since 2016, Fluitec builds sterile heat exchangers under license from Calorifer. Calorifer did invent a lot of good technique for heat exchangers for pharmaceutical applications, but they stopped their production in 2016, and so we started to produce these products under their license. These heat exchangers are used for pharmaceutical applications, and the characteristics of these heat exchangers are we have a double tube sheet. So inside the tubes you have the product. Around the tubes we have the heating cooling liquid, and between the product side and the heating cooling side there is a constructional gap, and with this gap we ensure that you don't have a leakage from the product side to the heating cooling side or opposite way. These heat exchangers are built with absolutely no dead spaces on the product size. We can handle the roughness of the surface down to 0.4 micrometers. We can have them with one or even with more passes per side, and these heat exchangers usually they are completely drainable. And for sure, they can be cleaned in place and also sanitarized in place. And we deliver them completely with optional fully welded insulation. So then you can even clean or sanitize these heat exchangers in an autoclave. We also deliver these heat exchangers in different materials. So 316Ty, 316L, and also very highly special alloys like the 1.4539. This is 309L. And we can also deliver this out of Hastelloy and other high alloy grades. So that was it. Short presentation about our products.